Oxidation of alkenes. Okay, now when we have oxidation of alkenes, there are two things that you need to take note of. That is the difference. Okay, so first of all, oxidative cleavage of alkenes means carbonyls are formed, meaning that you just like cleavage on the double bond, and then what is you do is just combine with oxygen. Okay, so there are two reagents used. Okay, one we call it ozonolysis, where you must have ozone, and then you must have zinc and water. Okay, you must first add ozone, then followed by zinc and water. So that's why we label 1 and 2. Okay, another one is CH3 dimethyl sulfide. Okay, so you can use zinc water or dimethyl sulfide. Okay, so what is special about this? I will just highlight this part. If you have one hydrogen here, it will become aldehyde. Okay, so this one is for ozonolysis. However, if you are using hot KMNO4, acidic hot KMNO4, if you have one hydrogen here, it will become carboxylic acid. Okay, if you have two hydrogen, one carbon with two hydrogen, then you are going to get carbon dioxide and H2O. So remember, for ozonolysis, if we have hydrogen, the hydrogen remains the same. It will not become carboxylic acid or carbon dioxide and water. Okay, now I want to show the difference. Okay, so first of all, okay, I have hot potassium permanganate. Okay, so I'm going, if I will see if there's any hydrogen or not. Okay, there's one hydrogen. So one hydrogen, I'll change it to OH, means it become carboxylic acid. Okay, another one is ozone. Okay, ozone means ozonolysis. Okay, ozonolysis, you must write 1 and 2 on the arrow. Okay, then one ethyl cyclohexene. Okay, so what happened is when you draw the double bond, you'll find out that there will be one hydrogen. But remember, for ozonolysis, hydrogen remains the same. Okay, now the difficult part would be how to draw if let's say you want to break the cyclic. Okay, so first of all, you calculate how many carbon do you have, starting from the double bond. 1, 2, 3, 4, 5, 6. Okay, so you draw 1, 2, 3, 4, 5, 6. Okay, then only you see, okay, for example, you label, because this one has one substituent, so we label number 1. Okay, so carbon number 1 has ethyl group. Okay, so just remember, just break it off and just combine with oxygen. Okay, so this is for the cyclic. Okay, now another one. We can identify the position of CC double bond. Okay, let's look at the question. A hydrocarbon compound Q reacts with ozone, then work up with dimethyl sulfide, forms, okay, let's look at this. There are two products here. Okay, so when there are two products here, so how are we going to identify? How are we going to know what is the reactant? Simple. Just make sure that when you draw the products, make the C double bond O carbonyl side by side, and then you combine them to become CC double bond. Okay, remember this is ozone. If ozone, the H just remains there. We don't have to make it to become OH or anything. Okay, and then by the way, it is just combining. We don't have to do any other thing. We just need to combine. So we can tell that the CC double bond is at carbon number 2. Okay, now another one. A hydrocarbon W reacts with hot acidified. Okay, and then you can see here we have COOH and CO means we have carbonyl, and we also have carboxylic acid. Okay, fine, don't worry. What we do is you draw first, but what I will usually do is I make the C carbonyl group become straight. Okay, and then how many carbon do I have here? 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5. The sixth one you can actually draw here, or like what I draw, CH3, because later I want to combine it. Okay, so what happened is, after I draw like this, make sure my C double bond is the C double bond, the side is clear. Okay, then I just combine these two. Okay, so when I combine these two together, it will become cyclic, because it means that the two C double bond O at the end of the chain combine. These two combine together. So your final answer will be 1-methyl cyclopentene. Okay, and then there is this one substituent here. So this part you can see from by giving, if the question has two carbonyl group, it's telling you that it is a cyclic structure. Okay, so that's all for oxidation. Remember, ozonolysis, hydrogen, if let's say we have hydrogen remains unchanged, but if KMnO4, potassium permanganate, if one hydrogen becomes carboxylic acid, two hydrogen becomes carbon dioxide and water. Okay, so that's all for this part.